Welcome to Groom's on-demand presentation covering online SCR and CO catalyst cleaning. The focus of this webinar is to answer all the questions that we get leading up to a project all the time within 15 to 20 minutes because your time is valuable. Online cleaning is a great service that allows any plant that uses emission catalyst to focus on the big picture and not have to worry about emergency shutdowns or running at limited capacity. Let's talk about how you can focus on making more money and product. We're going to cover 6 main points today: process capabilities and how the system works. Port installation. You don't have ports? No problem. Some common questions and challenges that we see daily. Safety. Fifth, quantifiable value. What can this service really do for you? And lastly, we'll introduce a new case study from a recent project you all might be able to relate to. A little bit on the speakers. My name's Steve Houghton. I'm the VP of Sales at Groom. Today we're going to be discussing the refining and petrochem space. We do have a few other divisions that you can see here. Ray Langton is also joining us. Say hi, Ray. He's a regional sales manager with Groom with over 20 years of experience in this space. He's a wealth of knowledge. So, Ray, speaking of Ray, he's going to discuss some of the capabilities of a turnkey cleaning and port installation.
Great. Thanks for joining us today. Thank you, Steve. Just to start, the port layout is probably the most critical part of our planning stage. It helps us facilitate access to ensure that we can clean as much of your catalyst surface as possible. If you can provide unit drawings for your wall design, all we would need is the wall thickness, your insulation depth. Do you have a liner plate? Do you have positive or negative pressure? And are there any interior impedances, beams, columns, any other obstructions? We would need to know about that. And when we do port installations, we typically prefer to do one port installed at a time to ensure there's no unit interruption. But in an emergency situation, we could discuss doing multiple ports at once in order to get you back at peak operational performance. Before we do that, we would need to do a review to make sure it can be done safely. And once we reviewed, received, and evaluated your drawings, we can propose a port layout diagram, which you can see here. The number, size, and shape of the ports will allow our cleaning lance to access the catalyst bed for maximum cleaning benefits. When placing the ports, like you can see in the diagram on the slide, we will need to have the proper placement and orientation. Again, this will depend on if you have a horizontal or vertical flow or any interior impedances. These are all factors we have to consider. In units where there's a horizontal layout, where the floor is open, like a grading system, as opposed to a catalyst resting on beams supports, we've been asked if we can clean through the grading, and the answer is yes. In that instance, we would just need to increase the vacuum to take into consideration the extra distance away from the catalyst face. The important thing to remember is that this is a repeatable process, basically an investment in plant stability. Once the ports are installed, you can do a routine online cleaning anytime you want to keep your facility running at peak performance. Can you clean your catalyst online? The answer is yes. We can and have serviced all catalyst manufacturers, any age from brand new to 10+ years in service. All designs can be cleaned, whether corrugated, extruded, pleated, or if you have a small or large pitch. Prior to making any recommendations, we can do an online inspection, usually with your online existing inspection ports. As you can see here in the picture, this will help us determine the level of fouling and the condition of the catalyst. When we have these images and information, this will help us determine the cleaning process and the equipment necessary to provide a maximum benefit for your cleaning. An important safety item to consider is, what is your current operating temperature? Most catalyst systems operate in the 700 to 800 degree range. This is important information as it helps us determine the necessary PPE and cleaning equipment to provide work safely and efficiently. I'll cover some of this in detail in a case study at the end of our presentation.
Thanks, Ray. We get a lot of questions on, which catalyst can we clean? The SCR, also known as the DeNOx catalyst or NOx catalyst, is the most prominent used in this space of refining and petrochem, but many of you who are listening to this also have a CO catalyst, which usually is the first line of defense in the gas path and very prone to masking. So it is a candidate for online cleaning. We can certainly clean both SCR and CO catalyst, as they both require the same process to clean them online. So no matter what type of catalyst, it's very common to see obstacles that need to be considered in the cleaning design. No one unit out there is exactly the same. So there's three main or common obstacles that we see, and I want to just introduce how we deal with each one, so you feel more comfortable with it. Ray's touched on a few of them, but I'll dive in a little bit deeper here. The first off is the module grid. There's a lot of 90-degree angles created by the grid that allows material masking debris to accumulate. In this particular instance, we're going to have a custom lance tip as a solution to get into that corner and pull vacuum and be able to clean it effectively. Second, it's not uncommon to see structural beams through the middle or around the perimeter of the duct, which can create an obstruction. We're going to design a lance orientation and design, as well as port location, to account for this so we can gain full access. And lastly, as Ray touched on, grading or a catalyst retention system creates a gap or void between the cleaning surface and the catalyst face itself. In this particular case, we can attack it two different ways, sometimes both, either a custom tip to account for that space and also to increase vacuum and effectively clean the surface with a greater vacuum pull. So the answer to your question, if you're concerned about stack particulate, it is not an issue or should not be a concern. Since we're only pulling vacuum and not back blowing as we would with a traditional offline cleaning, and online we're pulling vacuum only. Any debris that we liberate is pulled into the vac bag, and we use up to 27 inches of pressure, which is more than adequate to collect the debris and not have it go downstream. So safety first. A lean crew is not necessarily better for this type of work. I know that lean is a buzzword to drive a lot of different projects, but it's very important to lead with safety. In doing so, what we do is have a crew large enough to rotate men or operators every 15 to 30 minutes, so that we can reduce or eliminate any kind of heat fatigue concern. A proper cleaning system design puts the stress on the cleaning equipment itself and not the user, which is a big benefit. So what we want to focus on here is letting the equipment do the work. High heat PPE is utilized for all crew members and not just the folks on the top of the unit that are doing the cleaning. It's important to note that the vac line itself also gets hot, so we're going to engineer a tempered air system there to make sure that we mediate any kind of dangers along the way of the cleaning process. So what does an online catalyst cleaning really do for you? Let's let the numbers talk for themselves. Ray's going to introduce a few of the deliverables that our clients are used to seeing.
Right, Steve. Yeah, I wanted to spend some time on this information as this is what our customers ask most. What benefits can I expect from the online cleaning? And we just listed out a few here and just wanted to cover them. These are typically the results that we can accomplish. First being increased conversion. Your catalyst was designed to your specific conversion requirements, and keeping it clean helps in this process. Second, we get ammonia to the active conversion sites. If you look at a piece of catalyst the size of your thumbnail, it has the active surface area of basically the size of a football field. When you have fouling on that surface, the entire flow behind the catalyst blockage won't be used. And this causes a problem when you test your catalyst. If your other catalyst is being used efficiently and you test the blocked area where the catalyst is not being used, the test may tell you that your catalyst has more remaining life than it actually does. And if you put it back in service, there's a possibility it may fail before your next scheduled outage, which causes obviously a big problem. Next, cleaning enables even distribution. Again, we want to use the entire catalyst bed for maximum conversion efficiency. Also, it will minimize ammonia slip. When you're using the active sites efficiently, you don't have to use excess ammonia to make your conversion. And in many cases, we see that the savings in ammonia usage actually exceeds the cost to do the cleaning. From an environmental standpoint, we meet your permit. You want to make sure that you're meeting permit limitations. You don't want to open a can of worms, being out of compliance, and then have to deal with an environmental audit. That's just headaches for everybody. From your equipment, you want to control your back pressure. This will help unnecessary wear and tear on your equipment. And increase production. If you're running at reduced rates because of your permit limitations, cleaning your catalyst will allow for increased production and, equal important, increased revenue. And finally, like we mentioned before, the cleaning process is repeatable. You don't have to wait for an emergency to do a cleaning. This is basically an insurance policy that'll keep you up and running, that you can clean whenever you'd like. This next slide I'd like to talk about, we try to examine the root cause of your problems. We can keep coming out to clean your catalyst when it gets dirty, but if we can eliminate the source of the problem, we can make your equipment run more efficiently for a longer period of time. We just don't want to be a service provider. We want to be a solution provider for you. And one way we can help diagnose problems is through the use of a permanent sampling grid. This is a multiple zone grid of stainless steel probes installed across the catalyst bed. The probe locations are predetermined and are attached to stainless steel tubing that is fed back to the base of the unit, where they are attached to access ports. And in this slide, you can see the blue tags in the picture. They indicate that the specific point of where that probe is on the grid. At these access points, readings can be taken to see if you're having any plugging, ammonia slip, or seal issues. Basically, in a perfect world, we have a 1-to-1 ppm NOx to ammonia ratio, but that's not always the case. And as you can see in the graph there, the dark red areas are areas of concern. And then we can use this information to help diagnose your specific problem. When we evaluate the information, we can then address the issues that we believe to be the root cause of what your problems that you're having. When you do an online cleaning, you want to use a service provider who has the experience and understanding of how the catalyst was designed. Just trying to vacuum debris off the face can actually lead to more damage when the catalyst was simply masked. As you can see here in these pictures, the catalyst was scratched and impacted by someone who didn't know what they were doing. Since those areas are now damaged on the surface, all the catalyst behind them will go unused, as no airflow will be able to penetrate the catalyst bed. This will cause an increase in ammonia slip and a decrease in your conversion. Some items to check before beginning a cleaning is vacuum. You need to know what vacuum to pull in order to do a thorough cleaning without actually collapsing the face of the catalyst. Make sure to have the proper cleaning tips so you never touch the face of the catalyst. And you want to have the correct counterbalance on the cleaning lance to operate efficiently and to prevent stress on the cleaning technicians. And lastly, you want to use someone with experience.
Fantastic, Ray. Thank you. Now I get to introduce a case study from a recent project that we completed at a West Coast facility. It's a refinery that had experienced a recent upset and refractory let loose coating their SCR. This caused obvious issues downstream, one of which was the SCR not being able to convert NOx, and also it being masked increased back pressure. The plant was forced to run at limited capacity, which hurt revenue and output, and it was not getting any better with time. Sometimes you're lucky enough for these things to go away on their own. This was not one of those cases. The plant had not even ruled in the option of online cleaning, as they had no way of accessing the catalyst while the unit was running. So in reviewing the unit design, what we did is we're able to propose a system, a series of ports based on size and port orientation and location, we're able to design a system that maximized catalyst face access and would allow us to clean the catalyst on time now and any time in the future that they did have another upset, if they did have one. So we had some fantastic results from this project, and Ray's going to introduce some of those now.
Yes, and this installation of the cleaning ports will allow cleaning to take place at any time in the future, like we mentioned before. There will be no shutdown if the catalyst gets masked again. Again, this is basically an insurance policy to keep you up and running. When we did this cleaning, our cleaning reduced the back pressure by 55%, back to their original design pressure. We worked 4 days around the clock to clean the catalyst, and this prevented what would have been 3 days of complete shutdown. And we know when you shut down, there's always additional issues come up, leading to more delays and more lost revenue, more costs for any other repair items that you may have to do. After the cleaning, NOx conversion returned the permitted limits, and the unit engineer told us that the cost of our cleaning was basically a fraction of the lost revenue that would have happened if there was a shutdown. Some other items to go over, as Steve mentioned before, but our safety of the crew is extremely important. You can see here the PPE they're wearing. When we're working at high temperatures, we need to take the proper heat safety precautions. Since heat is escaping through the ports, we continually monitor the temperature and adjust our PPE accordingly. We need to know what the unit temperature is. We need to know if we can stand on the unit directly, or do we need to build scaffolding to work safely above it. You can see here we use high temperature stainless steel hoses. The temperature of the hose is monitored by a safety watch. We make sure that we can operate in a safe manner. The vacuum truck operator monitors hose temperature before it goes to the truck, and we can open ambient air mixing valves so no damage is done to the equipment. Again, we use only high temperature compliant stainless steel hoses to perform our cleanings. The size of the hose is dependent on how much vacuum we need to draw. And we also use high temperature filters so we don't damage the bag house, causing schedule delays in the cleaning, which would put you at more risk. Additional crew protection. Like I mentioned before, we have an additional heat safety monitor when doing online cleaning. This crew member is responsible not only for maintaining the temperature of the equipment, but also acting as a timekeeper to rotate the crew regularly so they avoid excessive heat exposure. To perform a good cleaning, we need a safe and healthy crew. Steve and I'd like to thank you for joining us today. Our contact information is listed here, and if you have any questions, please feel free to reach out to either of us. We're here to help with any issues that you may have. So again, thank you and have a great day, everybody.
Thanks for joining us, everybody. Have a great day.